Assalamualaikum. My name is Siti Nurlina binti Nur Azmi. My matrix number is AE19003.
Assalamualaikum warahmatullahi wabarakatuh. My name is Arifah Nukalisha binti Khalid. My matric number is AE190057.
Assalamualaikum warahmatullahi wabarakatuh. Saya Nurul Rozana binti Abdullah, pelajar tahun 2 dari Fakulti Kejuruteraan Elektronik dan Elektronik.
So next, this is for the manual calculation. We need to obtain the Fourier series equation from the waveform. So based on the waveform, we got the piecewise function. Next, we need to solve the Fourier series equation. We need to find A0, AN and BN. For A0, we know the equation is 1 over t integral t0 ft dt, and we solve the equation. We got the answer is 4. Next, for AN, we know the equation is 2 over t integral t0 ft cos and omega t dt. We solve the equation and we've got the answer is 0. Next, for Bn, we know the equation is 2 over t integral t0 ft sin and omega t dt. We solve the equation and we've got the answer 16 over n pi. And we know the n is odd and 0, the n is even. So this is the Fourier series equation. Next, we need to find analysis Fourier series equation, and we've got the answer is 16 over n pi. So next, we need to obtain impedance from the RLC circuit. Let's look at the RLC circuit. So from the circuit, we know that the R1 is 2 ohm, R2 is also 2 ohm, the capacitance is 4 farad, the inductance is 6 Henry. Next, for inductive reactance, we know the formula is 2 pi FL. Then we solve the equation, we've got the answer is J and 6 pi ohm. Next, for capacitive reactance, we know the formula is 1 over 2 pi FC. Then we solve the equation, we've got the answer is negative J over N4 pi ohm. Next, we need to find the impedance for second loop. The formula is bracket ZR2 plus ZL parallel ZC bracket. Then we solve the equation, we've got the answer N6 pi minus 2J over N8 pi plus Jn square 24 pi square minus J. Lastly, we need to find the total impedance. The formula is ZR2 plus ZL parallel ZC plus ZR1. We solve the equation and we've got the answer N22 pi plus Jn square 48 pi square minus 4J over N8 pi plus J bracket N square 24 pi square minus 1 bracket. Next, we need to find current at each branches. For the DC component, we know that N equal to 0, V naught equal to 4, where I naught equal to 2 ampere. For the harmonic of waveform, we know Vs equal to 16 over n pi L 0 degree. For I1, the formula is Vs over Zt. We solve the equation and we've got the answer N48 pi plus Jn square 384 pi square minus 16 over n square 22 pi square plus j bracket n cube 48 pi cube minus 4j n pi bracket. For I3, we know the formula is ZL over ZR2 plus ZL parallel ZC multiple I1. We solve the equation and we've got the answer Jn square 48 pi square plus j bracket n cube 144 pi cube minus 1 bracket n 48 pi plus jn square 384 pi square minus 16 over n 6 pi minus 2j n square 22 pi square plus j bracket n cube 48 pi cube minus 4j n pi bracket. For I2, we know the formula is ZR12 over ZR2 plus ZL parallel ZC multiple I1. We solve the equation and we've got the answer. N 32 pi plus jn square 56 pi square minus j bracket n 48 pi plus jn square 384 pi square minus 16 bracket over bracket n 6 pi minus 2j bracket n square 22 pi square plus j bracket n cube 48 pi cube minus 4j n pi. So next we need to find voltage at each branches. For V1, we know the formula is ZR1 over ZR2CL multiple Vs. We calculate and we got the answer is 16 over n pi bracket n 60 pi plus gn square 48 pi square minus j over n 6 pi minus 2j. In the circuit above, V2 and V3 is parallel, so the value are same. The formula is ZR plus ZL parallel ZC over ZR2CL multiple Vs. We solve the equation and we've got the answer. In the time domain for the n harmonic, we know Vs equal to 16 over n pi L negative 16 degree. So next we need to convert current obtained to time domain. So from the current obtained above, we need to convert to time domain. Next, we need to replace into the basic equation to convert. Then we solve the equation and we've got the answer. Next, for I2, we did the same as I1. So this is the equation and how to solve it. Next, lastly, we go for the I3, same as I2 and I1. We replace it into the formula and we solve it. And this is the answer. Lastly, we need to find power at one branch of the circuit. So this is the formula of the power. So from this circuit, we choose branch 3. So we replace the value into the formula of power. Then we solve the equation. So the answer we've got is 5.05 watt.
Assalamualaikum and selamat sejahtera to Dr. Fairuz. My name is Siti Nurlina binti Nur Azmi. My matrix number is BEV20203. Now I will present for the simulation part. In our circuit, the component that we use are for R1 2 ohm, R2 2 ohm, capacitor 4 farad, inductor 6 Henry, and for the V supply is V sine. The reason we use V sine are to get sine graph. Now let's run the simulation. This is the graph that we obtain for the voltage that flow to capacitor. This is the combination of voltage graph that flows to capacitor R1, R2 and inductor. This is the graph that we obtain for the current that flows to capacitor. This is the graph for current that flows to inductor, resistor 1 and resistor 2. Now let's compare between manual calculation and simulation in PSpice. For I1, the manual calculation that we obtain are like this. For the simulation part, we obtain the sine graph like this. For the I2, we obtain the manual calculation and the simulation are like this. For I3, we obtain the manual calculation like this, and for the simulation, for the I3 and I1 are almost the same. For V1, we obtain the manual calculation like this, and the graph sign is like this. For V2, we obtain the manual calculation and the simulation like this. For V3, the manual calculation are like this, and for the simulation part like this. For the voltage graph, it almost gives the same shape of sine graph. That's all for the simulation part. Thank you.